Everyone should have a basic understanding of the equivalencies among fractions, decimals, and percents, and should also be able to work some basic word problems using ratio, proportion, and percent. This is the kind of math that comes up all the time. Still, I find that kids can get to 8th grade and not honestly understand what this is all about. So I'm going to start by looking at a fraction that you have actually memorized. 1/8, as we know, is equal to 125 thousandths, which is equal to 12.5%. To think about these connections, some things that you should know. If I say 12.5, anything followed by a percent sign means out of 100. 12.5 out of 100. And I also know that the fraction bar means divided by. And when I'm dividing by 100, what happens to my decimal point? It moves 2 places to the left. If I'm dividing by a power of 10, it moves as many places to the left as there are zeros. So if I say 12.5 divided by 100, I get 0.125. So that's one of the ways that you can think about this. Going from a percent to a decimal is moving the decimal point 2 places to the left. I can also read this, and hopefully you can read decimals. That is 125. You read it as though there were no decimal point, right? And then you put it in a fraction with a 1 over this many zeros. So that's thousandths. Well, we want to have a percent. We need only out of 100. So I can put a decimal point in there, meaning that this is the same as 12.5%. A way to think about the 8th going to the decimals, you could say 1 divided by 8. And honestly, if you just put that in your calculator, you're going to get 0.125. You could also say 1, to go to a percent, you could say 1 out of 8 is the same as how many out of 100. And you will find that it is 12.5. So, those are sort of like the big reasons behind this. If you're going from a fraction to a decimal, all you have to do is divide the numerator, by the denominator. Because the fraction bar means divided by. It's as simple as that. To go from a decimal, and then from a fraction to a percent, you would take that decimal. Actually, let's erase that. So from a fraction to a decimal, to a percent, you take that decimal and move the decimal point 2 places to the right. Let's take a look at why that is. Using our example of 1/8, when I did 1 divided by 8, if I divide that, I find out that that is 125 thousandths. But I want to know how many that is as a percent. So I have to say that that's this. I move my decimal point 2 places to the right. So a decimal to a percent, 2 places to the right. And you can follow that logic and say percent to a decimal, 2 places to the left. I've had some kids just get mixed up about which one goes which way. If you think about it, if I say, for example, 8%, that really means 8 out of 100. And when I'm dividing by 100, that means I'm moving it 2 places to the left. So I would take this 8, and that is 8 hundredths. 8%, 8 out of 100, 8 hundredths. 8 out of 100, though, would need to be reduced. So that is 4 goes in here twice and goes in here 25 times. The problem is it's kind of a moving target. You can move one way or the other, but just going from decimals to percents, one way to keep in mind is just think D comes before P in the alphabet. So if I write them down like this, to go from decimal to percent, it's 2 places to the right. To go from percent to decimal, it's 2 places to the left. If I want to talk how to change a decimal to a fraction, really all you need to do is read it, hear it, write it, and then reduce. So if I were to say, I don't know, let's say 50.53 is 53 hundredths because there is what I always said before, you read it as though there were no decimal point, which is 53, and then the denominator is a 1 with this many zeros. Okay, and in this particular number, it can't be reduced. If I said that, I'd read it. That's 8 1,000ths, and I can see that 4 goes into both of those, 2 over 250, and then it's 1 over 125. 8 goes into 1,008 times. I knew that. 1 125ths. All fractions need to be reduced to lowest terms. Going from a percent to a fraction is really easy. Percent to a fraction, the denominator is always 100. So if I want to know what, I don't know, 64% is, that is 64 over 100. And in this, I can see that 4 goes into, then you also have to reduce it. 4 goes into 64 6 times, and it goes into 100 25 times. Percent to fraction, you always have 100 as the denominator. I think those are all of the basic things that you need to know going back and forth. You have to sometimes have things, if I want to write this is where it gets a little confusing. What is 7,000ths as a percent? Well, you know, if I'm changing this decimal to the percent, if I keep track of that, I know it's like this. And that's one way to do it. It's 0.7%. But those percents that are below 1 are sometimes confusing to people. And if I said 625%, and I want to know the decimal of it. Well, in this situation, I'm starting at p and going to decimal, so I'm going to have to divide by 2. I mean, move the decimal point 2 places to the next. So this is the number 6.25, which makes sense because it's over 100%. It's more than 1, so that's 625. That's just the easiest thing to do. Mostly, if you know about moving the decimal points, you should be pretty much okay. What if starting with a percent that's more than 100, like for example, if I say 175%, well, I'm going from a percent to a decimal, I just move it over 2 places. That's also, I could say 175 over 100 if I want to do the fraction. 175 over 100, and then I reduce. 25 goes in here 7 times and fourths, and sometimes you can leave it like this, or 1 3/4. Or you could go back from here and you could say 1.75 is 1 75 hundredths, which is 1 3/4. It's really not hard once you sort of get the hang of moving across, back and forth. Similarly to this, you really do need to know some method that you can count on for converting among these things, or to solve some basic word problem kinds of things. Like if I want to know what is 23% of, I don't know, 28. You could always do the is over of thing. Part to whole equals what part out of 28. Of means the whole thing, so this is part, this is the whole, and you can solve that proportion, and then obviously it's not going to come out evenly, so you can do that. But you will have to round most likely. But you could also just say 23%, as we know, as a decimal. I'm moving it 2 places to the left. That's the decimal equivalent of 23%. Of means times. So if I have a calculator handy, it's actually quite a bit easier to say 0.23 or 23 hundredths times 28. And you'll find out that equals 6.44. Okay? What about, it says, 14 is, I don't know, 12.5% of what? I could immediately recognize that that means 12.5 over 100 part to whole. 14 is, so 14 is the is, out of what? We don't know. So of course we can do it like that. We could also change this to an equation. 14 is 0.125, changing this to a decimal, times the number we don't know. So another way to do this on your calculator is to divide 14 by 0.125, which would give you 112. So there are those problems. One way or another, if this is what makes sense to you, it's fine with me if you stick to it. The final one, let's see, like for example, if I'm giving you a test and there's an odd number of questions, like I think sometimes there's 23 questions, if somebody gets, I don't know, 18 out of 23, 18 questions out of 23 is what percent? Well, here the part to the whole is 18 out of 23. And what you don't know is what percent, what out of 100. When I'm correcting your papers, I just go immediately to my calculator and I say 1800 divided by 23, because it's always going to be multiplied by that So 1800 divided by 23 is 78.2. Unfortunately for that person, I round to the nearest whole number, so that would be 78%. We've spent a lot of time talking about the fraction destroyer, but in fact, sometimes it's helpful to use a decimal destroyer because kids tend to be more accurate. People tend to be more accurate when they're dealing with whole numbers. 36 plus 0.4x. I could just keep the decimals and use my calculator and all that, but if I didn't want to have decimals and I want it to move, I want everything to be in a whole number, I could multiply this entire equation by 10, because multiplying by 10 moves each of the decimal places over one place, making this 12x equals 360 plus 4x. It's the same answer you would get if you just kept it as decimals. What would happen would be, it would be 1.2x minus 0.4x equals 36 plus 0.4x minus 0.4x. So we'd have 0.8, 8/10 of x is 36, and when you divide by 8, you'd still get x equals 45. I do think that it is often wise to do a decimal destroyer. And you choose what you're multiplying by based on how many places you need the decimal point to move. The final thing that you have to do for homework tonight, the final thing you have to do is to begin working with kinds of discounts or markups in price. The example in the book has a sleeping bag that costs $75 and is on sale for 40% off. So we've got to take 40% of 75 off of the $75. That's one way to do it. So how do we find 40% of 75? 40% as a decimal is 0.4. Of means times. So that's what the discount would be. And then we have to subtract that from 75. So 40% of 75 is $30. And 75 minus 30 is $45. What's easier in these kinds of problems is to, rather than do this whole subtraction thing, to say, if you're getting 40% off, you are 40% off means you are paying 60%, right? Because 100% minus 40% is 60%. When you know it like that, you can just go straight to your calculator and say 75 times 0.6, and you get 45. So if I'm getting 30% off, I'm paying 70%. If there is a 12% markup, the new price is the old price, 100% plus the 12% markup. Whatever it is that you have to do to have it make sense to you is what you should stick with. Good luck.